All right, thanks guys. Thanks for coming. I'm excited about this one. I think this topic is going to be fun. It's going to be interesting. Might not be something that everybody does every day, but understanding principles of graphics and animation, particularly in JavaScript, I think are pretty helpful. When situations do arise that might be useful to you, you'll have a good foundation of where you can go from there. So I just want to kind of get a read of everybody. Can you raise your hand if you've used the Canvas API? Yeah, that's a pretty good number. Maybe half the room. Or if you've done any sort of like CSS animation, raise your hand. Cool, a lot more people. Awesome. So this presentation is going to focus on the JavaScript side of animation. It's subtitled Part 1. The next donuts is going to be Part 2, and it's going to be focused on. Oh, sorry. Let me turn down my volume. It's going to be focused on CSS and DOM animation. So just a little, let's see, where's my mouse? There we go. This animation is a 3D particle simulation. There are a lot of particle simulators out there. This is one of them. I think that this probably represents one of the hardest things you could do in computer science, is particle simulation. You know, when Pixar renders their movies on server farms, that's what they're doing, is trying to get particle simulation for water right and things like that. So I just want you to look at this for a second and appreciate that there's probably 100,000 objects that JavaScript is managing, and it's rendering them in 3D time or in real time in 3D space. And then appreciate that not only is this a real-time animation on the front end, it's also I can manipulate it in 3D space to see different perspectives. This is all happening in real time with lighting, with the particle effects. And then, not only is it a real-time animation in JavaScript in 3D space that you can manipulate your perspective, you can also interact with the animation. So this may be the state of the art in terms of rendering in a browser. But I think it's important to understand the modern state of the art, to understand where we came from, to understand the history. So in the beginning, there was hypertext. Hypertext was a language that described documents. This is the first website. It's still hosted at the same URL on CERN. If you look to, you can ask, how can I help? It's responsive, by the way.
It is?
Yeah.
Does it?
Look at that.
Oh, wow.
But I love these suggestions. How can I help? Let's see. Send us suggestions. We love to get mail. So if you'd like to have a suggestion about the internet, you can send mail to www-bug@cern or info.cern. Or let's see. There are a lot of other ways. Let's see. The web needs raw data. I've thought that if there's one thing the web needs, it's more data. So you can send that data to CERN.
Only if it's raw.
Yep. So this is the web. This is the building block that the web is based on. And it's primarily academic, scientific. This was libraries connecting to libraries. This was government research institutions connecting to other government research institutions and sharing data. So it wasn't soon after the web came about and we moved from hypertext that in this scientific document sharing world, a need arose to have some sort of complex graphical representation of objects. So enter VRML. Virtual reality modeling language. And in 1994, they had a different understanding of what virtual reality meant than we do today. So this is one of the first VRML applications running. It's blood platelets. This is a 3D illustration of platelets. And so this is what it was used for. It was scientific. It was sharing information from libraries to libraries and things like that. Probably one of the most famous VRML examples is the Netscape Navigator. This was incredible. You could fly around this planet that had the big N on top of it. And I mean, we kind of chuckle about it now, but I mean, this is state of the art. When you came from that CERN website with text to doing something like this is really, I mean, this is pretty incredible if you imagine the step forward that this took. So exit VRML, enter Java. The Java applet was probably one of the, at the time, the most widespread ways to provide application graphics and animation inside an application. A typical use was showing videos inside of an applet. They're used for a lot of training videos, and if you find some old intranet, old corporate sites, a lot of times you'll still see some Java applets with old training videos and policy type stuff on them. And that was a common use for it. But anything you could write in Java, you could render on a website. So you could use complex tree applications. Any sort of, really anything you could write in Java, you could embed in an applet, and that would run in your browser. After Java, Flash. And we kind of malign Flash, but if you think back, I mean, we look back with 2020 vision, but the things that Flash did for the web were really incredible. If you think about the type of complex layouts, animation, the type of navigation that could be done, the interesting experiences, if there was no Flash, we would not have YouTube. Right? If there was no Flash, we would not have probably most of the Web 2, Web 3, whatever 0.0 type sites you do now. Even though now we can look back and say that Flash probably was used for more than it should have been. In addition to interesting layouts, it also provided us with endless laughs. And it also provided us with endless unusable photo galleries.
Don't you mention that, or I guess to actually mention the Google interactive stock chart, which is still alive.
There you go. Yeah, and Flash to this day, if you want to use something on it, if you want to interact with the clipboard, there's no way to do that other than including a Swift file. Now, you cannot interact with an operating system clipboard unless you include Flash.
But it's coming.
It's coming. Yep. Yeah.
Holding Safari is one method. Every other browser can do it with Safari.
Awesome. Silverlight is another browser-based plugin that provides kind of a way to create complex applications. It's another application programming interface that can be embedded in browsers. Silverlight's still pretty well used today. Arguably, well, not arguably, but quantitatively, the most popular streaming website in the world uses Silverlight heavily because Silverlight, unlike browsers, you can have DRM in Silverlight. You can embed video codecs that will have encryption keys in them that Silverlight can have to protect copyright owners, and that's something that Netflix needs for some reason to protect their copyrights or to protect the IP owners that they stream. But they are experimenting with HTML5 video. So on some devices now, if you go, it'll load HTML5 video, and on many it will still load Silverlight. So these are all browser plugins, right? These are not things the browser can do. These are just applications you have to install, right? You go and you have to install Flash, you have to install Java, install Silverlight. And nowadays, if you look at a lot of the websites, your experience you get is similar to this. I think to understand browser plugins and the place and the history they had, it's important to understand the application from top to bottom of how applications are executed. At the very bottom of the stack, there's hardware, right? Actual hardware, CPUs, GPUs, and these provide instruction sets. Like you've heard of x86. That's an instruction set that you can use to say, move a bit one place over or add these two bits together. On top of that instruction set is an operating system. That operating system itself gives instructions as APIs that can be consumed to program for an operating system. At this level, any application can run and consume an operating system API. In our case, it's a browser. Browsers consume operating system APIs, and they expose APIs of their own to the code that we write, which runs on a browser, which is HTML, JavaScript, and CSS. These take advantage of browser APIs. The plugin model it really just punches a hole through a browser and can run directly on the operating system or directly on an application that itself is running on an operating system. So if you have a Flash thing, you can think of it that there's literally a hole in your browser and Flash is running there right on the operating system, which you can see kind of the security problems with that, right? If your browser is totally sandboxed and its process is secure, you can't smash stack, you can't access memory on someone else's block of memory. Maybe Flash has that problem. And so you can write a malicious program for Flash that runs in a browser. And the user never has to accept it or reject it. It's just 2 pixels at the bottom of your screen, and it's going to corrupt your memory stack, or Java, or any other type of application. And so this is the primary reason that browser vendors have been moving away from the plugin model. In fact, I think just last week, Firefox turned Flash off by default. If you want to execute Flash, it's going to give you a little notification window, and you have to accept it. So there's a different model when it comes to graphics programming. That's rather than allowing other applications to run, breaking through the browser sandbox, why don't we just beef up the graphics APIs that the browser can expose? And, well, spoiler alert, that's what this has done. That's what they've done. So different types of graphics. There's 2 broad categories of graphics, like graphic families, raster and vector graphics. Raster graphics are defined by pixels, things like photos that are arrays or 2D arrays of pixel values and colors. You'll commonly find it's all the formats that we're used to: JPEGs and GIFs, PNGs and bitmaps. Yeah, that's what I said. That's what I said. GIF. Yeah. Vector format is they're defined by equations and paths. If you wanna make a mountain, maybe you're gonna make a really smooth mountain and it's defined as a sine wave or some sort of Bezier curve. They're commonly used for figures, charts, and illustrations. So like an Illustrator file or an SVG, those are vector graphics. One difference is that if you zoom in, if you do your CSI zoom and enhance, your raster graphic is going to get more and more pixelated. Your vector graphic will smoothly scale, but you're not really going to get that much more information because you're just smoothly scaling into a path that's defined by a function or an equation. These are 2 examples, right? These are a picture from Rio and then a vector graphic of that same location. So can you imagine the image on the left? If you had to define that using shapes and paths, that would be a huge, huge file, right? I mean, every little pixel is going to be, here's a rectangle at this coordinate, or here's a circle, instead of just the actual pixel values. Excuse me. The image on the right, if you defined that only by the pixel values, it would be kind of a waste of space because there are a lot of colors that are just contiguous blue, contiguous yellow. And so defining this in terms of shapes and paths is a very compact representation. So the browser provides different ways to access these graphic formats. Raster graphics are most commonly an image tag, a video, or a canvas element. Vector graphics, you can do SVGs, like an inline SVG or an SVG in an image file. A font is a representation of a vector graphic. If you do icon fonts, those are vector graphics. This is going to focus on the Canvas API, the rest of this presentation. And so what are the biggest question everybody asks is, what are the practical uses of Canvas? So graphics, image manipulation, complex animation. And when I asked the question at the beginning of this presentation, it's like about half of everybody raised their hand that they'd used Canvas before. So I'm wondering if maybe 2 or 3 people can just say, what did you use it for? What were the uses that you found for using the Canvas API. Yeah.
Image cropping and resizing.
Image cropping and resizing, perfect. Yeah, who else? Go ahead.
I used it to use render graphics in WebGL.
Render graphics using WebGL.
Yes.
Perfect, that's awesome. Yeah, who else? Yeah, go ahead. Oh, cool. Rendered a gradient to it and used it as a color picker. Yeah, that's a great way to use it. So on LDS.org, here are a few things that I thought of. You know, we've got an interactive animated music player that's written in Flash, and so you can't use it on your iPad in church. The primary section of LDS.org has children's games, like coloring books or puzzles, that you also can't use on phones or iPads because they all use Flash. Here's probably one of the most complex tree structures that you'll ever find, a family history chart. Some sections of this use Canvas and SVG and lots of technologies on Family Search's website. And they've done a great job making it compatible across any browser or device. The Joseph Smith Papers uses a canvas to do deep zoom images. You can just zoom in forever on these documents, and it will stitch pictures together using the Canvas API. Some other ones that I thought of, already mentioned, image cropping, putting watermarks on things, maybe doing some sort of data modeling or charts or visualizations. So we're going to get, from here on out, we're going to get into actual code. In the DOM, this is the most simple representation of a canvas. It's just a canvas tag. It's not a self-closing tag. It's a open and close in a canvas tag. But you probably want to have some way to access it using JavaScript. So you're going to put an ID because you want to access that specific canvas tag. Can you put anything inside of a canvas tag? Yes, you can. It's what shows up if it's not supported. And so a canvas tag itself, if you want to use it in a graphical way, that interaction happens through JavaScript, not through the DOM. Anything in the DOM is going to show up similar to like a NoScript tag, where whatever shows up there, it's only going to show up if that's not supported on the device or browser. So Canvas is not magic. When a lot of people, you think of these animations and movies, and it's kind of this black box magic thing. It's really probably one of the most simple data structures that's been known to computer science. It's an array of pixel values. And when you look at a canvas rendered, it's just a rendered version of that array of pixel values. So an array, this is the most simple canvas element you could look at. This is an array of pixel values, RGBA. So red, green, blue, and alpha, which is like your opacity channel. And that's what this looks like. This is a single pixel. It's red. There you go. Art. Yeah, all right, you guys went great. So the canvas array of pixels is a one-dimensional array, meaning that if you have a large image, each of these rows is going to be like wrapped into just one single array. And then as that's rendered, they do some math and figure out, okay, if it's 50 wide, the element 51 is the next row down, because this is the most compact for memory data structure to represent it. And so this is a representation of this picture. Art. Again, 4 pixels, red, green, blue, and black. What's that?
Assuming a height and width of 2.
Yeah. Yep. Yeah. If your canvas element was 4 wide, then this would be just a row of red, green, blue, and black all in one row, or a vertical stack, right? If it was a width of 1, but no matter what the width is, the data structure representation of it is always going to be this one-dimensional array of pixels. So interacting with the canvas, you use a context. The canvas you can think of like your artboard. It's an actual, imagine it like an actual canvas, right? And your context is your toolbox. It contains the colors, the tools that you use to manipulate the canvas, whether you want to You want to rotate the thing. You want to move it from side to side. You want to change fill colors, stroke colors, anything like that. So the context exposes an API of tools that you can use to manipulate your Canvas artboard. So the Canvas API is fairly straightforward. You can fill a rectangle, draw a line. All right, that's it. No, this is like 1/4 of the APIs. So this presentation is not going to be an API walkthrough. That would be too extensive and too boring. So what I'm going to do is just show some simple examples that illustrate principles that you can use. And then when you want to figure out how to do it more in depth, you can look up those APIs for the Canvas context. All right, so here's the first demo. This is kind of like a hello world of Canvas. So can you guys comment on my font size, please? Is that okay? Too small? Is that better? Is that readable?
Yeah.
Okay. So a single canvas element, and just for the demonstration, I drew a border around it in CSS. So here's the JavaScript. We get the canvas by the ID, and we find we get the context of that canvas. That's our toolkit by doing this .getContext2D. There are other contexts. I'm not going to cover them, but one other context that was mentioned is WebGL. That's a amazing graphics library based on OpenGL for the web that you can basically write like C++ functions that are going to be executed to do real complex like shaders and ray tracing and just real amazing stuff. So this is 2D. We're going to fill a rectangle. This first value is an x value. The next value is y. The next value is the width. And the next value is the height.
Right.
That's right, the height. The height. All right, and we're gonna put some text on the screen. Fill text. Hello world, and that's the x and the y coordinate. So, art, like I mentioned. Yeah, go ahead.
So what about the color? How do you, where does the color come into play?
Great question. Thinking ahead. So the context, like I said, it's our toolkit. We can change the different styles of the context, like the fill color or the stroke. So if you use graphics like an Illustrator program or something like that, or Photoshop, fill means like paint bucket, fill something up. Stroke is a border. So you can assign different values to that. So I could say ctx dot fill style is red. There you go. And so you can change the style, and then that's like picking your paint color basically, putting on your palette. You're saying I'm using red, and then everything else you do after that is red until you change it or reset it.
So if you wanted the text to be black,
Yeah.
you just copy the line and put it right in between.
You could, yeah, you could do that. There's also another technique you could do where you can save the state of your context and then restore it. Save ctx dot restore. There you go. So I'm saving the state on line 3, basically meaning whatever you're at now, make that my save point, and then do what you want, and then you're saying, resume game from your previous checkpoint.
Can you save multiple states? Like, can you give it a name and save that?
I don't know.
State?
Yeah, that's a great question. That would be really neat if you could do that. That would be useful. I'm not sure if you can do that or not. All right, so there's our hello world example. So here's a little more complex example that uses the principles of that hello world example. Let's see here. Again, font size. Is this all right? Too big? How's that? That work? Okay. So in this example, I have 3 images, and here they are. These are 3 images I just downloaded from the home or from an article on LDS.org. So examples of the type of images that you commonly see in a real life website that we'd be using. So put this over to this side, this over to this side. So we're going to use Canvas to enhance these images a little bit. So the first thing we're going to do is find all images on the page, and then we're going to loop over them, doing this for each here. Okay. So we found each image, we're looping over the images. Now for each image, we're going to create 3 new variables. We're going to create a new canvas element, and this is just an element in memory, right? I'm not actually assigning this to the DOM yet. And we're going to create a new context for that canvas and a new image element. And then whatever the current image is, right, because we're looping, we're going to take that image and assign the source of the image to the source of our photo, which is this new in-memory image element. And then we're going to do some stuff when the photo loads. So first thing we'll do is assign the height and the width of the canvas to be the image height and width, so they're the same size. And then we're going to get an arbitrary x and y coordinate, which I'll show later, and then draw the image on the canvas. So does that make sense? So we have image elements, and we've taken those image elements and basically copied them to 3 different canvases. All right. So the next thing we're going to do is say on the image that I just drew, or on the canvas I drew, I'm going to write this text, and that's a little copyright notice. And I'm going to do it at that x and y coordinate. And then replace the image tag with the canvas element that I just made. So let's save this. And there we go. So zoom in a little bit. These images, you can see there's little copyrights there, right in the bottom left corner of each image. It says copyright IRA 2016. And so probably the most common problem putting text on images, especially when that image is dynamic from a content contributor. You don't know the background of the image, the color, you don't know what the contrast ratio is going to be, right? So we can use Canvas to solve that problem. So I talked about the canvas is represented as an array of pixels. Here's an API from the context that allows me to read that pixel data. So I'm saying at the x and y coordinate, read a chunk 50 wide and 3 tall, and then get that data. That's an array of pixels, an array of RGBA values. So I'll comment that. And then these 3 lines, I'm going to do some math that will, the first expression, or this first function, this reduce function, basically sums up all the values. So every RGBA value, add them all up to get this great big value. And then the next thing we're going to do is divide that by the number of pixels in our, or the number of R's and G's and B's and A's in our array of values. So this is creating an average. So just to recap, I asked the canvas, or I asked the context for a little square chunk of the picture in pixel data, and then I averaged all those pixels out. And so this average now, we can set a threshold and call that our brightness. So if the average is less than 200, meaning it's going to be darker, make the fill color white. If the average is greater than 300, make the fill color black. So you can see on the center image there, the copyright is on a darker section of the canvas, so it's white. On the bottom image, the copyright is on a dark or a light section of the image, and so it's black. So I'm just arbitrarily setting white and black, but you could do some math and say, whatever the average color value for this section is, pick a color that's like on the opposite side of the color spectrum. Or Yeah, go ahead, Bruce.
If anybody's having the same problem I'm having, there's only 2 images up there. There's not 1, 2, 3, 4 steps worth of images, so you're only looking at the bottom right
Oh, yeah.
corner and of that, the image with all the purple cutouts on it, and then the bottom right corner of that.
Oh, yes, thank you. So this is Children, Families Are Forever. This is one image. It was in an article. I made that bigger to see the copyright. So there's these 3 images. So the top one is black, the middle one is white, and then the bottom one is black. And you can change in Canvas. You can change font size and change all sorts of stuff. Something else you could do if you didn't want to have a canvas, if you wanted to have these be back in their original image tags, you could take this canvas and you can, instead of reading as an array of pixels, you could ask it for its value as a base 64 encoded PNG. So you could take the data of the canvas and put it back in the image tag. So people could still download the image, people could still copy and paste the image. It would be just a normal image to the user. Unbeknownst to them, you took it off their screen, manipulated it, and put it back when the page loaded. So this is one example of a practical Canvas use. Yeah, go ahead, Bruce.
For the record, there are no options to save and restore. It's just save it and restore. That's it.
Save and restore. So another question was, can you save like multiple save points?
Yes.
And you looked it up, and the answer is no. You can only save and restore. Thanks.
Yeah, question.
Yeah, let's go in the back.
So if you do a save as on the photo,
Uh-huh.
does it include the text?
Yeah, so in this
Photo?
case it's a canvas element, and so I'm not sure, but you can put it back into an image, and then it would include the copyright.
Can you try it real quick?
Sure. Yeah, let's try it. So it's save image as, download.png. So I'm just going to put it on my desktop to make it easy to find. No, let's put it in my documents here. So test.png. All right, let's try it. There it is.
Wow.
Cool. Thanks for asking me to try that in front of everybody. If it didn't work out, we'd be having a problem right now. So this is a way that you can have your content contributor. They can dump in 1,000 pictures from General Conference, and then you automatically get this free copyright notice, right? You don't have to spend all this time or some batch job in Photoshop to include something, And a copyright's one example. You could do watermarks. You could have it be the name of the speaker. Like if maybe you put the name of the speaker as a data attribute, put that on there. Anything you want. Any sort of graphic manipulation you want. Yeah. Oh yeah, Colt.
So doing something like that and processing an image or playing values on an image, what kind of hit is that as far as performance goes? Is it pretty lean and mean? Or is it
Because the underlying data structure representation of a canvas is a one-dimensional array of pixels, it's fairly simple. If you ask for a shape, then it has to do some math, right? Because it's not just saying, get me this section of the array. You need to say, get me this 50, and then skip a bunch, and then give me this 50, and then skip a bunch. And so it's doing some matrix math on that array. But it's no more complex than any other matrix math, and I think it's probably faster because it's optimized by the browser. Yeah.
What's the DOM representation at this point?
So the DOM representation at this point is 3 canvas tags. So if we wanted them to be images, like image tags, like they were initially, so on this line right here, 29, we replace the image with the canvas. An alternative thing to do would be we could have got the contents of the canvas as a base 64 encoded, a JPEG or a PNG, and then inserted that back into the image as the source, the image source.
So can you prevent the canvas then from being saved?
That's a good question. I don't know. I mean, there are various techniques that you can do to prevent somebody from click. You know, you can disable clicking, but anybody that knows how to use the inspector can get around that kind of stuff.
They can always screen grab.
Well, just thinking,
Yeah.
because you don't have the hrefs, right? So you don't have the tags for the originals. So the person would have to somehow get the original source in order to figure out what the images were.
They'd have to do
Yeah.
some job.
Which they could, and they just look in the network. They look in the network tab, right? Because in the network tab, the images are downloaded initially. So if you're concerned about that, something you could do is instead of running this on the client side, you turn this into a Node script, and you run it on the server side, and then the images are output from Node with a little copyright. If you're going to go that far to do it on the server side, you might use ImageMagick or some sort of other server graphics library. It might be faster than Node. So there are pros and cons to doing that.
Canvas is using those libraries under the covers. It's no canvas is under the covers. It's not like you're losing anything going to no canvas there, and you have an API that's familiar.
Cool. Yeah, thank you. Was there another hand? Awesome. Okay, cool. I'm glad it seems like everybody liked that. That's always a fear, right? People don't like my demos. All right, so here's another. We're going to go back to our initial Hello World example to talk about animation. So the same setup. We have a canvas tag. I put a border around it just for the convenience of the demo. So let's go right to the JavaScript. So we on line 1 and 2 we get our canvas, get the context, and then skip down a little bit. Past this all uncommented stuff or commented out stuff. We do the same thing. We put a rectangle and we put some text. In this case, I'm putting it at half the width of the canvas minus 10, and its width of the rectangle is 20, which means I'm putting it in the center of the canvas. And I'm doing some more math to put Hello World just so they're in the center of the canvas. Okay, so to have animation, think about what are the principles of animation. Remember your paper flip book, right? You've got a series of frames or a series of drawings that you're showing fast enough that it appears like motion. That's the same principle we're going to use. So in order to do this, in order to draw this, we're going to have to draw it over and over, which means this is going to be a function, right? So now we're going to have a function called animation loop. And it's not showing up on the screen because we're not calling that function now, right? And so to call that function, I'm going to ask the window to call animation loop, the function we just created, at the next available frame. You could call it immediately, but for performance, you can say request animation frame, which is asking the browser, hey, the next time it's convenient at your current frame rate to animate something, do this function. All right, so not much has changed, right? Still pretty simple. So let's get to the animation of stuff. Okay, so the coordinate system of a canvas is such that the top left corner of a canvas is 0, 0. This is not like your algebra class where 0, 0 was in the center, then you had quadrants. 0, 0 is referring to the pixel at position 0, 0, which is the top left corner of the canvas. And so we want to rotate. I want to rotate this around to the center, so it's going to spin around. So what we're going to do is we're going to ask the canvas to do a translate function to translate the context to the center point of the canvas. So we're saying, translate to width divided by 2 and height divided by 2. And the next thing we're going to do is, when it's done, translate it back, right? So if we draw again, we don't now have this offset shifted thing. And now we're going to rotate the canvas. Ta-da! That was awesome, right? It rotated 1/10 of 1 degree. And the reason is because we're calling request animation frame, but we're not calling it over and over, right? We've just looked at one frame of our animation. And so within our animation function, within animation loop, we're going to go and recursively call, it's like pseudo-recursive. We're not actually recursively calling ourself, we're asking another function to call ourself. So here's some ready for magic. Wah, wah. What did I forget to uncomment? Angle, that's right. Let's see here. Something I'm missing. Oh, the initial angle. Right now, angle's undefined. There we go. Sweet. So we're spinning this around over and over. Amazing. Perhaps an unexpected result was that it's doing this like drag effect, right? It's not smoothly animating it. It's like repainting it over and over and over. That's because think back to our array of pixels. Every time this loop happens, it's saying, turn it a little bit and then paint on our array. But at no point are we actually like clearing the screen off. And so to get some smooth animation, we're going to go ahead and save the state of the canvas, restore it, and then change our fill style to white, and then draw a rectangle that's going to cover the whole canvas. So there we go. Every frame we're drawing a white rectangle and then redrawing this little Hello World example at a different angle. And you notice it seems to be spinning up a little bit, right?
It's way better than Blink.
So basically what I'm saying is I'm recommending this is the homepage of LDS.org. So this line right here, I'm saying angle plus equals 0.01. Every frame, the angle is going to increase, right? So the first frame, it's going to change by 1 degree, and then 1.1 degrees, and then 1.2 degrees. So it's going to get faster and faster around. So this is a linear animation, right? So it's a constant speed animation. If we increase it by some amount every time, the animation is no longer linear in time. It's now quadratic, meaning it's the animation speed is increasing every frame. If we wanted to make this not a quadratic equation animation, we could now say some times function. So now it'll get exponentially faster. And wait for a second, you'll notice the cool like helicopter effect. All right, cool. Somebody want to do the sound effects? All right, that probably won't work well for the recording. All right, here's our next example. Yay, it's a Hello World example again. Go ahead and look at this. This is the same example in terms of HTML, except this time I've included a little span that we're going to put some data in, like some debug data. And so something to think about. Okay, here's a question. The speed of our animation was related to the number of frames, right? Every frame, the animation would speed up. Does that mean that your animation is going to look the same on every device? Right? Yeah, nodding heads. No. On a slow device with a slow frame rate, your animation will go slower. On a fast device with a fast frame, your animation will go faster. That's why a couple months ago I loaded my old Warcraft 2 Tides of Darkness on my computer and I played it up, and it was impossible to play because they did not use a time-based frame rate. They just used like, hey, DOS only ticks this many ticks a second, so that was the frame. So we want to tie the animation to be time-bound. All right, so what we're going to do is we're going to declare a frame rate. A really great, if you can hit 60 frames a second, that's awesome. Anything close to that, you're good. It starts to get really noticeable and kind of janky if you're down in the 20s. I think like a film, I think is what, 24 frames a second. So if you're lower than that, you're janky. That's like the technical term of jank, right? And I'm not just saying weird. It's jank-y. And so we're declaring a frame rate in milliseconds, 1,000, so a second divided by 60. We want 60 frames per second, or 60 frames per 1,000 milliseconds. All right. And instead of calculating, saying our angle is, 1 every time for every single frame rate, what we're going to do is we're going to say the angle is actually 360 degrees times this expression. So we're going to say whatever the current millisecond is right now. What's in any given second, it's millisecond 600, and then it's millisecond 200. And we're going to divide that by 1,000. So this is going to give us like a percentage, right? At what current percent of the second are you in milliseconds? Times the number of degrees in a circle. And then let's go ahead and just draw that out. So if you think about a second, right? So let's go ahead and log. So just to make sure that this is actually running in real time, I have a second function that's going to run and output the current second count at the bottom of the screen. So you can see the animation is now time bound. It's not frame bound. And we can increase or decrease the frames per second by changing this ratio. So if we want to change it to 40 frames per second, it's still time bound. See, animation, it still takes a second to go around, but it's more jank-y. You can get real low, 10 frames a second, right? Real noticeable. So here's a film, 24 frames a second. This is when you go to the movies, this is what you're seeing. Movies don't have retina screens though, so we recommend 60 frames a second. So any questions about this before I move on? This has some math. This has some, yeah, go ahead.
Other than frame rate, and this isn't related to Canvas, but other than frame rate, why didn't you use request animation frame rate?
So I could have. I think I didn't, just to keep the example more simple, to narrow the scope of the example just to what we're showing here. You could do set interval, and then the set interval is a function that requests animation frame for that frame. Yeah, good question. Yeah, any other questions? Go ahead.
I've got a question about context. So I want to animate multiple things. Each one will have their own context.
Yes, that's right. Every canvas element has its own toolbox, its own context.
Can you overlap canvases above each other?
Sure, you could. I mean, you could CSS position them on top of each other. I'm not sure though, like if you could get opacity bleed through from one to the other. If you wanted to do that, to layer things on top of each other, it might be easier just to make a bigger canvas and have two different regions that you're drawing in. Yeah, any other good question? Any other questions? Yeah, Jim in the back.
If you set it to like 1,000 frames per second, what's frames at the bottom there? Because it's giving too much math.
I don't know. Let's try. Yeah. So I mean, Chrome's using a lot of CPU, but what's new there? Yeah, I don't see a noticeable spike. I think Colt's right. You're probably going to hit your monitor refresh rate, which may be slightly higher than 60 frames a second. I'm not sure what that is. 70 or something like that. Yeah.
Just something interesting about the Canvas is that on your mobile devices, it's actually hardware accelerated, where sometimes your CSS animations, if you're not animating certain properties, it's not hardware accelerated, so you'll get a janky animation. Where Canvas, everything you do in Canvas, it's instantly hardware accelerated on your phones and devices. I'm
so glad you brought that up, and I'm going to repeat that just for everybody and for the recording, that on devices that support it, the canvas is going to be rendered by the GPU. It's hardware accelerated. And I think Chrome is a hardware accelerated browser. And so right now this is not rendering on my CPU, it's rendering on my GPU. So it's going to be much faster. I mean, the GPU's literally built for this. So, yeah, thanks for bringing that up. Any other questions? All right, I've got, let's see, one more example here, and we'll wrap it up. So we talked a little bit about drawing. We talked a little bit about animation. This example is going to real quickly cover events on a canvas. And events on a canvas are not anything different than what you're already used to. So let's just look at the JavaScript. Let's see. So in the previous examples, I was pulling in images from those image tags. In this case, I'm just opening a file. So that's the same as the example we've already seen. We're opening a file and then drawing the image to the screen. I have a little helper function called drawImage. It's just going to draw this frog. And this frog, by the way, is a transparent PNG. It's only the outline of the frog. Under the frog, I'm drawing this little nice yellow background. Because this is a coloring book, paper isn't perfectly white. It's kind of this nice aesthetic, eggshell. Don't tell anybody I just said eggshell, by the way. So, all right, so we're going to add some events. So in this is going to be a drawing example. So there are three events we need to listen for. We need to know if the user has their mouse pressed down or if their mouse is lifted up, and we need to know if they're hovering over it at that same time. So here's two events. This is the same sort of event listener that we've done for everything else. Mouse down, mouse up, and it's going to set a Boolean to true or false, whether the image is being pressed. And then on the mouse move event, we're going to check if they're currently pressing, if they're in a pressing state, request the animation frame, and set the fill color to red, get the X and Y coordinates of the mouse, and at those X and Y coordinates, draw a circle. There's not a draw circle function, there's an arc function. So I'm creating an arc that goes 2 pi big, which is a circle. Filling that with red. And then on top of the circle that I draw, I'm redrawing the background image, the frog. See this draw image? This is the helper function. I'm going to draw the frog again. So there's our little drawing. Sweet. So what if I want to draw on the frog? I'm coloring under the frog, like a coloring book sort of thing. So it would be, really, I'm not exaggerating, it would be trivial to extend this to have maybe a color picker that chooses your fill color. You could have a little slider up and down that chooses the radius of your circle. In probably half an hour, you could turn this example into a full-fledged coloring book for your kids. And then maybe instead of mouse up and mouse move and mouse down, you change that to touch start, touch end, right? And now you give your kids an iPad with this web page on it, and they have a coloring book that you just made for them in 50 plus maybe another 20 or 30 lines of code. That's the power of Canvas. It's pretty cool. And that is it. Thank you. So I think we're officially out of time. If anybody wants to leave, you're free to leave. I'm happy to stay as long as anybody wants to answer questions. So, Drew.
You save the frog after you've drawn on it? It saves the drawing as well.
Yep, yeah, you can. You can say, Canvas, and then get that image as a JPEG and print it out or something like that.
Or just right-click save as.
Yeah, or right-click Save As. You could save it as an image. Yeah. All right, thanks everybody.